Welcome to the deep dive. Today, we're going to shrink down, way down to the subatomic level
Yeah.
to explore the world of quarks,
Quarks.
the tiny particles that, build the universe
The universe.
as we know it.
As we know it.
You've sent us some excerpts from, scientific analyses and overviews.
Right.
And believe me, this stuff is seriously cool.
Yeah.
Get ready to have your mind blown wide open.
It's true. These little guys, quarks,
Yeah.
they're like the fundamental building blocks
But-
of matter.
Of matter.
Everything you are is ultimately made up of these tiny particles.
Okay, so before we dive into the deep end,
Yeah.
can you give us a quick Quark 101? What are these things?
Right.
Why should we care?
Well, imagine you have a Lego set, right?
Okay.
You've got all these different bricks, and you can put them together to build all sorts of amazing things.
Mhm.
Quarks are kind of like that.
Yeah.
They're the Lego bricks of matter, but way cooler
Okay.
and more complex.
I like where this is going. So quarks are like the fundamental pieces,
Right.
but what makes them so special?
Yeah.
What sets them apart from, say, electrons?
One of the most fascinating things about quarks is that they never hang out alone.
Oh, really?
They're always found in groups bound together by a super strong force.
Wow.
It's like they're inseparable buddies.
Inseparable buddies,
yeah.
huh?
Yeah.
So if we can't find them on their own,
Right.
how do we even know they exist? It's like trying to study a shadow without any light.
That's where it gets really interesting.
Okay.
We know they exist because of their effects.
Okay.
Think of it this way.
Mm-hmm.
You can't see the wind,
Right.
but you can see the leaves rustling.
Right.
Same idea with quarks.
Okay.
We see their impact on other particles.
Gotcha.
And that's how we know they're there.
Okay. I'm starting to get the picture here.
Good.
But why are they always stuck together? What's the glue
Right.
that binds them?
It's all thanks to something called the strong force. And this force is governed by something called color charge,
Okay.
which is a bit different from the colors we see in the everyday world.
Hold on. Color charge.
Yeah.
We're talking like
Yeah.
red, blue, and yellow quarks?
Well, sort of. Instead of mixing to make white light,
Okay.
we're mixing color charges to make matter.
Oh, wow.
Mind-blowing, right?
Yeah.
They're not literally red, blue, or yellow,
Okay.
but we use those names to describe the different types of charges
Okay.
that quarks have.
Okay.
It's like a code
Uh-huh.
that determines how they interact.
Okay. I'm starting to see how this all fits together.
Good.
So each quark has a color,
Right?
and these colors determine how they interact with each other
Right.
through the strong force.
Yes.
But you said they're always found in groups.
Yes.
What kind of groups are we talking about?
The most common groups are called hadrons,
Hadron.
and they're made up of 2 or 3 quarks.
Okay.
Protons and neutrons, the particles that make up the nucleus of an atom, are both hadrons.
Wait a minute.
Yeah.
So the stuff that we're made of,
Yeah.
it all boils down to these tiny little quarks interacting with each other?
Yeah.
That's incredible.
It is.
But it still seems kind of strange that we can't ever see a single quark on its own.
Right.
Why is that?
That's because of a phenomenon called confinement.
Confined.
It's like each quark is connected to its group
Okay.
by an unbreakable rubber band.
Oh, wow.
The more you try to pull them apart,
Yeah.
the stronger that force gets,
Interesting.
keeping them bound together.
So it's like they're playing a never-ending game of cosmic tag,
Yeah,
always connected to their partners.
exactly.
Wow.
And that's why we never see quarks hanging out solo.
Okay.
They're always part of a bigger particle confined by that incredible strong force.
Okay. This is all blowing my mind. But in a good way.
Haha.
We've got this idea of quarks being these fundamental building blocks,
Right.
always grouped together by the strong force and their color charges. But how do we actually know any of this is true? How did scientists figure it all out?
That's where some incredible experiments come in.
Okay.
Scientists devise clever ways to smash particles together at incredibly high speeds.
Uh-huh.
Kind of like using a subatomic microscope to peer inside the heart of matter.
So we're talking particle accelerators, right?
Yes.
Like the Large Hadron Collider we hear about in the news.
Right.
The one that smashes atoms together at nearly the speed of light.
That's the one.
Wow.
One of the first big breakthroughs came back in the late 1960s
Okay.
at a place called the Stanford Linear Accelerator Center, or SLAC.
Let's see.
Scientists, they were essentially shooting electrons at protons, like tiny bullets.
And by studying how these electrons bounced off the protons,
Yes.
they could tell what was going on inside.
Exactly. The results of these experiments showed that protons weren't just solid blobs.
Uh-huh.
They had an internal structure.
Wow.
And that structure turned out to be made of these point-like particles
Okay.
that we now call quarks.
It's amazing to think that we can learn so much about something so tiny
I know, right?
by smashing things together at incredible speeds.
Incredible.
But back to those quarks you mentioned, that there are different types,
Yeah?
right? It's not just one size fits all
You got it. We call them flavors of quarks.
flavored.
And there are 6 of them. Up, down, charm, strange, top, and bottom.
6.
They have different masses and charges, which affects how they behave and what kinds of particles they can form.
Okay, so we've got these 6 flavors of quarks,
Yeah.
all with their own unique properties.
Yes.
Are some flavors more common than others?
The most common are the up and down quarks.
Okay.
They're the lightest, and they're the ones that make up protons and neutrons.
Right.
The building blocks of atoms.
So everything we see and interact with is ultimately made up of these up and down quarks,
Pretty much.
along with electrons.
Hmm.
It's incredible to think that the entire universe is built from these tiny particles.
It really is. And what's even cooler is that by studying these quarks, we can learn not only about the matter that makes up our world, but also about the very early universe.
Hold on. How do quarks connect to the early universe?
Oh.
Are we talking like Big Bang stuff?
You're right on track.
Really?
Remember those particle accelerators that smash atoms together?
Right.
Well, in places like the Large Hadron Collider, when scientists smash these particles together at super high speeds,
Yeah.
something incredible happens for a tiny fraction of a second.
Uh-huh.
They recreate the conditions that existed just moments after the Big Bang.
Whoa. So we're talking about recreating the primordial soup of the universe in a lab.
It is pretty wild.
That's insane.
And within that soup,
Yeah.
quarks and gluon,
Uh-huh.
the particles that mediate the strong force,
Right.
aren't confined inside protons and neutrons like they usually are.
Right.
Instead, they're free to roam around, creating something called quark-gluon plasma.
Quark-gluon plasma. Okay, now that sounds seriously cool.
It is.
What exactly is that?
It's a state of matter that's unlike anything we see in our everyday lives.
Okay.
It's incredibly hot and dense.
Wow.
And it's thought to be the state matter was in just a few microseconds after the Big Bang.
So by studying quark-gluon plasma,
Yeah,
we can get a glimpse into what the universe was like in its earliest moment.
exactly. It's like having a time machine,
Wow.
allowing us to peek back into the very beginning of the universe
Okay.
and study the fundamental forces and particles that shaped everything we see today.
Wow.
Pretty amazing, right?
This is all so fascinating. I feel like we've only just scratched the surface of the quark world.
There's so much more.
But before we dive even deeper,
Yeah,
let's take a quick moment to recap what we've learned so far.
sounds good to me.
Okay. So we started with the idea that quarks are these tiny fundamental particles that make up everything we see around us.
Right.
They're like the Lego bricks of matter,
Uh-huh.
but way cooler and more complex.
Way cooler.
Then we learned that they never hang out alone. They're always found in groups, thanks to the strong force and their unique color charges.
Right.
And these groups of quarks are what make up the protons and neutrons that form the nucleus of every atom.
Yes.
We also talked about how scientists study quarks by smashing particles together at incredible speeds,
Right.
recreating the conditions of the early universe, and giving us a glimpse into the fundamental building blocks of reality itself.
Amazing, isn't it?
That's a lot to take in.
It's true. But I think you summed it up perfectly. We've covered a lot of ground,
Yeah.
but there's still so much more to explore. In the next part of our deep dive,
Okay.
we'll delve even deeper into the strange and wonderful world of quarks,
Okay.
exploring their bizarre quantum properties and how they might even hold the key to unlocking some of the biggest mysteries of the universe.
Wow.
Stay tuned.
Welcome back to the deep dive. Last time we got a crash course in Quark 101.
Right.
We learned about their different, flavors,
Uh-huh.
the strong force that keeps them glued together,
Yeah.
and those groundbreaking experiments that revealed their existence.
Mm-hmm.
We even touched on how scientists are recreating the conditions of the early universe
Right.
in labs to study these tiny particles.
It's amazing to think that we can recreate the primordial soup of the universe right here on Earth, isn't it?
It is.
And by studying that soup, we're not only learning about quarks, but also about the fundamental forces that shaped the universe as we know it.
It's mind-blowing stuff.
Mhm.
But today I'm really excited to dive into some of the more philosophical implications of quarks.
Okay.
We've talked about how they behave in a way that's totally different from anything we experience in our everyday lives.
That's right. Quarks operate in the realm of quantum mechanics.
Right.
which is famous for being, well, a little bit bizarre.
Okay, so let's talk about quantum mechanics.
Okay.
It's one of those things that everyone's heard of, but very few people actually understand.
Right.
What are some of the key quantum concepts that apply to quarks?
One of the most mind-bending concepts is superposition. Imagine a spinning coin, right?
Okay.
Until it lands, it's both heads and tails at the same time.
Okay.
That's kind of like superposition, but with quantum particles.
Okay.
It means that a particle can exist in multiple states simultaneously
Right.
until it's measured.
So until we actually look at a quark,
Yeah.
it's like it's in this fuzzy, undefined state.
Right.
It's both here and there, spinning up and spinning down all at the same time.
Exactly. It's like the act of observation
Yeah.
forces the particle to choose a specific state.
Interesting.
And this is where it gets really wild.
What?
The act of measuring a particle actually influences its state.
Whoa. So we're not just passive observers.
Right.
We're actually participants in the quantum world.
Yes.
That's pretty heavy stuff.
Hmm.
But how does this all relate to quarks specifically?
Well, for one thing, it helps explain how quarks can interact with each other through the strong force.
Okay.
Remember those gluons we talked about?
Yeah.
The particles that carry the strong force?
Yeah.
Their exchange is a fundamentally quantum process
Okay.
involving virtual particles popping in and out of existence.
Yeah.
And this wouldn't be possible without the weirdness of quantum mechanics,
Right.
like superposition.
So even though we can't see quarks directly,
All right,
we can see the effects of their quantum shenanigans.
you got it.
It's like they're pulling strings behind the scenes, shaping the reality we experience.
And it's not just superposition that makes quarks so strange.
What else?
There's also entanglement,
Entangle.
which is another head-scratching concept.
Okay, lay it on me. What is entanglement?
Imagine you have two quarks
Okay.
that are linked together in a special way.
Okay.
Now imagine you separate them by a huge distance,
Mhm.
maybe even light years apart.
Wow.
If you measure the state of one quark,
Yeah.
you instantly know the state of the other, no matter how far away it is.
Wait, so it's like they have some sort of telepathic connection.
It seems that way.
They're communicating faster than the speed of light.
It does seem that way, but it's not quite that simple.
Right.
Entanglement doesn't involve any kind of signal or information transfer.
Right.
It's more like they're two parts of a single unified system,
Oh, wow.
even when they're physically separated.
Okay, that's wild.
Yeah.
It definitely challenges our everyday understanding
know.
of how things work.
Yeah, yeah.
But how does entanglement play into our understanding of quarks in the universe?
Well, entanglement is thought to play a key role in the behavior of quarks within hadrons.
Okay.
Remember those groups of quarks that make up protons and neutrons?
Right.
Well, the quarks within those groups are thought to be entangled,
Okay.
which affects how they interact
Yeah.
and ultimately how those particles behave.
So entanglement is like the secret ingredient
Yeah.
that makes quarks work their magic within atoms. It's like they're all part of this cosmic dance, connected in ways we're only just beginning to understand.
Exactly. And it's not just within atoms that entanglement is thought to play a role.
Oh, really?
Some physicists believe that entanglement may even be responsible for the large-scale structure of the universe.
Hold on, you're saying that the universe is connected on a fundamental level by entanglement?
Hmm.
Like everything is entangled with everything else?
It's a mind-blowing concept, isn't it?
It is.
And while it's still very much a theoretical idea,
Right.
it's one that has some fascinating implications.
Right.
If true, it would mean that the universe is much more interconnected and holistic than we might imagine.
I'm definitely feeling a sense of cosmic unity right now.
Good.
But let's get back to the nitty-gritty of quarks.
Okay.
Last time we talked about those massive particle accelerators
Yeah.
that scientists use to study quarks.
Right.
But you also mentioned something called lattice QCD.
Yes.
Can you remind us what that is and how it fits into the big picture?
Of course. Lattice QCD is a powerful computational technique
Okay.
that allows scientists to simulate quark interactions.
Okay.
Imagine you have a 3D grid, like a giant chessboard.
Okay.
On this grid, you place quarks and gluons.
And let them interact according to the rules of quantum chromodynamics,
Oh,
which is the theory that governs the strong force.
so it's like a virtual playground for quarks,
Right.
where scientists can control the environment and study how these particles behave.
Exactly. And by running these simulations on supercomputers,
Wow.
scientists can calculate things like hadron masses, decay rates,
Okay.
and other properties with incredible precision.
So it's like we're using the power of computers to peer into the quantum world, where
Yes,
things get really weird and wonderful.
precisely.
Okay.
And what's really cool is that Lattice QCD is allowing us to make predictions that can then be tested in experiments.
Oh, cool.
It's a beautiful interplay between theory and experiment, pushing the boundaries of our understanding of quarks in the universe.
It's like we're constantly refining our map of the quantum world,
Hmm.
filling in the gaps and making it more accurate with each new discovery.
Right.
But tell me, are there any practical applications for lattice QCD outside of pure research? It's a field that's still evolving,
Okay.
but there's a lot of potential. For example, it could help us design new materials with specific properties
Hi.
by understanding how quarks and gluons interact at the most fundamental level.
Yeah.
We could potentially engineer materials with unprecedented strength, conductivity, or other desirable characteristics.
That's incredible. It's like we're learning the language of the universe.
It is.
And with that knowledge, we can start to build amazing new things.
Yes.
But all this talk about quarks and quantum mechanics,
Yeah,
it really makes you think about the nature of reality itself.
it does.
What does it even mean for a particle to exist
Right.
if it can be in multiple states at once
Right.
or entangled with another particle across vast distances?
Those are deep questions,
They are.
and ones that philosophers and physicists have been grappling with for decades.
Wow.
The study of quarks has forced us to re-examine our basic assumptions about the nature of reality.
It's like we're peeling back the layers of an onion, revealing more and more complexity the deeper we go.
Right.
But before we delve too deep into the philosophical rabbit hole,
Yeah.
let's take a quick break to gather our thoughts.
Okay.
We'll be back soon to continue our deep dive into the world of quarks
Okay.
and explore what they might tell us about the universe and our place in it. And we're back, ready to wrap up our incredible journey into the world of quarks. We've covered so much ground from their quirky flavors and color charges
Right.
to their mind-bending quantum properties and their role in shaping the universe.
It's amazing how these tiny particles, once just a theoretical concept,
Yeah.
have revolutionized our understanding of matter and forced us to confront some of the deepest questions about the nature of reality itself.
Absolutely.
Yeah.
But before we close out this deep dive,
Right.
I want to revisit something you mentioned earlier.
Okay.
The idea that studying quarks could help us uncover new physics beyond the standard model.
Ah, yes. The search for new physics.
Yeah.
It's a driving force in the world of particle physics. You see, the standard model.
While incredibly successful in explaining a lot of what we observe,
Yeah.
doesn't quite have all the answers.
Okay, so it's like a really good map, but there are still some unexplored territories.
That's a good way to put it.
What are some of the big mysteries that the standard model doesn't explain?
Well, for one, there's dark matter.
Okay.
You've probably heard of it.
Hmm.
The mysterious stuff that makes up a huge chunk of the universe but doesn't interact with light.
Right.
We can see its gravitational effects, but we have no idea what it's made of.
Right.
The standard model doesn't offer any clues.
And then there's dark energy,
Yes.
the mysterious force that's causing the expansion of the universe to accelerate.
Exactly. And there are other puzzles, too,
Like what?
like the masses of particles. Why do some particles have the masses they do?
Yeah.
The standard model doesn't fully explain that either.
So there are these big fundamental questions that the standard model just doesn't address.
Right.
And that's where the search for new physics comes in. Precisely. Physicists are constantly searching for clues
Okay.
that might point to new particles, new forces, or even new dimensions. It's like trying to complete a puzzle where some of the pieces are missing.
Right.
And we have to use our ingenuity and creativity
Yeah.
to figure out what those missing pieces might look like.
And how does the study of quarks fit into this puzzle-solving quest?
Well, for one thing, quarks provide a window into the workings of the strong force,
Okay.
one of the fundamental forces of nature.
Right.
By studying how quarks interact,
Mm-hmm.
we might uncover hints of new forces or particles that haven't been observed yet.
So by pushing the boundaries of our understanding of quarks, we might stumble upon something totally unexpected
We might.
that could revolutionize our understanding of the universe.
Exactly. It's happened before in the history of science.
Right.
Sometimes the most groundbreaking discoveries come from unexpected places.
Yeah.
Who knows what secrets quarks might still be hiding?
It's exciting to think that we're living in a time where these mysteries are being unraveled. But tell me, are there any specific theories out there about what this new physics might look like?
Oh, definitely. One of the most popular theories is supersymmetry, or CUSY. for sure.
Yes, you white.
It proposes that every known particle has a superpartner,
Oh, wow.
a particle with similar properties,
Okay.
but a different spin.
So it's like every particle has a secret twin.
That's a great way to think about it. And if CUSY is true, it could explain some of the mysteries of the standard model,
Okay.
like the masses of particles.
And what about those extra dimensions you mentioned earlier?
Yeah.
That sounds like something straight out of science fiction.
It does, doesn't it? But the idea of extra dimensions has been around for a while in theoretical physics.
Okay.
Some theories suggest that these extra dimensions are curled up and hidden from our perception,
Uh,
but they could still influence the behavior of particles and forces in our three-dimensional world.
okay, now my brain is officially doing backflips.
Ah,
But this is why we love the Deep Dive, Rita. It's all about exploring the most fascinating and mind-bending ideas in science.
absolutely. And I think that's the beauty of studying quarks.
Yeah.
They lead you down these incredible paths of inquiry, forcing you to question everything you thought you knew about the universe.
It's like we're constantly expanding our horizons,
Yeah.
realizing that the universe is far more complex and wondrous than we could ever imagine.
I couldn't agree more. And who knows what incredible discoveries await us in the future.
Right.
Perhaps we'll find evidence for supersymmetry,
Yeah.
or those elusive extra dimensions, or maybe something even more bizarre that we haven't even conceived of yet.
The possibilities are truly endless. But one thing's for sure, the journey of scientific discovery is far from over.
Right.
And quarks will undoubtedly continue to play a starring role in unraveling the mysteries of the universe.
Well said. And I think that's a perfect note to end on.
I agree. We've taken our listeners on quite a journey exploring the fascinating world of quarks, from their basic properties to their mind-bending quantum behavior and their role in shaping the universe as we know it.
And hopefully we've sparked a sense of wonder and curiosity in our listeners,
Yeah,
inspiring them to continue exploring the wonders of science and the universe.
absolutely.
Yeah.
So to all you knowledge seekers out there, keep those minds questioning, keep those imaginations sparking, and never stop exploring the vast and mysterious universe we call home. Until next time, keep on diving deep.